frictionless bench. So this bench has no friction, so there's no opposing force in terms of motion there. Trolley A moves to the right with a constant velocity u equals 0.44 meters per second. Trolley B is stationary. So the moment you see this word, it means that the initial velocity of B is equal to 0 meters per second because it's stationary. Okay. Fig 2.1 shows A before colliding with B. The direction of A is to the right, and of course B is stationary. State the momentum of trolley B before the collision. Explain your answer. So the momentum of B is 0. Remember, momentum in simple terms, P is equal to mv, where you are multiplying mass, which is in kilograms, and speed or velocity, which is in meters per second. So that means the momentum of B is 0 kgs meters per second. Why do we say so? Because B is stationary. B is stationary. Stationary with 0 velocity. That's the idea there. So if you're multiplying anything with 0, you always get a 0, right? After the collision, the two trolleys are joined together. So if these two trolleys have been joined together, it means that after collision, we are going to be adding their masses, mass of A plus mass of B, right? They become one object, right? They become one object plus mass of B. They become one object after collision, right? And they will definitely move with the same speed because they'll be moving together. So after collision, the two trolleys are joined together and travel with a constant velocity of 0.18 meter per second to the right. That's very important, right? The mass of the trolley A is 0.75. Calculate the mass of trolley B. So in this case, we are going to use the law of conservation of momentum, right? Which states that total momentum before collision, right, equals total momentum after collision. So if we are to use symbols, we are saying, right, MA times UA plus MB times UB. This will always give us MA VA plus MB VB. Something like this, where U and V represent initial velocity and final velocity respectively. So in our case, we are told that of course we know that the initial momentum of B is 0. So this is a momentum of A before collision, momentum of B after before collision as well. And then these two guys are going to be combined in our case because we have one quantity there. So that means we have MA plus MB, right, multiplied by V. You can use just the one value of velocity there. Then let's substitute the values and see what we have, right? So we are going to replace the mass of A is 0.75. So this is 0.75 times the initial speed of A was indicated up there, right? It was highlighted up here. That's 0.44 meters per second. So this 0.44, right, plus 0 equals, right, since we are going to the right, it means we are maintaining the sign. We are now saying mass of A, which is 0.75, plus mass of B that we are looking for, times 0.18. Okay, and we can expand here. We can expand, right? Let's see what do we have. I think we can have 0.75 times 0.44, right, divided by 0.18 equals 0.75 plus mb. Right, you can split that. You can have some space there. Alright, let's see what we get from that division. Right, 0.75 times 0.44 divided by 0.18. Right, we get I'll leave it as a fraction because it's not yet the final answer. This is 11/6 equals 0.75 plus mb. So that means mb is equal to 11/6 minus 0.75. So minus 0.75, what do I get? Right, at first I'm getting, right, 1.08333 recurring. Right, this is mass of P. So if you look around again, our values are raw data values are to two significant figures, so we can actually round off these two significant figures, which will give us 1.1 kilograms. So this will be the mass of P, 1.1 kg. Right, I hope you got this one right. Law of conservation of momentum. Right, the trolley moves onto a rough surface. The trolley moves onto a rough surface which exerts a constant force F on the trolleys and brings them to rest in 2.6 seconds. So the fact that we're told that they are going to be at rest, so which means their final velocity will be 0. There's some kind of deceleration here, and from what we have, we are told their initial velocity u was actually 0.18. Let's go back and check there. Right, after collision, 0.18 meters per second, 0.18 meters per second. So we're going to use Newton's second law here, which says that F is equal to ma, but we are going to split that and have v minus u over t here. Right, and then from here we know the masses, we are adding the two masses, the 1.1 for mass B and the 0.75 for the other one. Okay, so we are coming down here, we're saying F is equal to, right, 1.1 plus 0.75 multiplying 1.8, sorry, 0.18, right, 0.18 minus 0 divided by 2.6. Right, let's see what we get here. Right, 1.1 plus 0.75 times 0.18 over 2.6. Right, I'm getting 0.12807, which is approximately equal to 0.13 newtons. 0.13 newtons. By the way, I think I made a mistake here. I need to come back and replace these values properly up there. Okay, this must be clear that it's a resistive force, so this will be 0 minus 0.18, so our answer will be negative because this is a resistive force. That's a resistive force. Okay, initial velocity is 0.18, final velocity is 0 meters per second. Right, it's important to check those things, make sure I don't make those mistakes. Right, a different rough surface exerts a smaller resistive force on the trolley. So if there is a smaller resistive force, it means that the trolleys will take longer to come to rest. Right, take longer to come to rest. Right, because the question is saying state how this affects the time taken during to bring the trolleys.